Hello children, how are you all? In this session, we will solve exercise 9.3 of algebraic expressions based on multiplication of a monomial by a binomial. If you need any help regarding this topic, you may watch this detailed video. So let's start with the first question. As discussed, the monomial will be multiplied to each term of the polynomial where it has 2, 3 or more terms. And while multiplying the polynomial, we will have to put it in brackets. We first multiply the signs and write the resulting sign before the terms. So, plus into plus plus, 4p into p, plus into plus plus, 4p into r, which becomes 4p square plus 4pr. Follow the alphabetical order in each term. Just observe there is one term in the first part and two terms in the second part which we are multiplying. So 1 into 2 is equal to 2 and hence we will get two terms in the final product. So this is how we can easily know as to what type of polynomial we will get in the answer. Like for the next one also 1 into 2 is equal to 2, so we should get a binomial. Let's solve it. Plus into plus plus, ab into a, then plus into minus minus ab into b, which eventually gives us a square b minus ab square. Now in the third part, binomial is before the monomial, but no problem, we will still follow the same method. So multiply each term of the binomial with the monomial. So plus into plus plus, a into 7a square b square, followed by plus b into 7a square b square. And this is the final answer. Similarly, in the next part we get a square into 4a minus 9 into 4a. And this is the final answer. In the fifth part, the monomial 0 will be multiplied with each term of the trinomial. So we have pq into 0 plus qr into 0 plus rp into 0. But 0 multiplied by anything is 0. So we get 0 plus 0 plus 0, that is equal to 0. Note here, we are not getting 3 into 1 equal to 3 terms in this answer because all the terms are like terms and so they add up to give a monomial. So if we get any like terms, we can always add them. Hope this method is clear to you and now you will be able to complete the following table. You may solve in the rough notebook and get the answer, or you can even find these products orally. Let me show the first one. So the monomial here is a and we have to multiply it to the trinomial b plus c plus d. Taking care of the signs, a into b will be ab. So the first term of the answer will be ab. And in the same way, I can write the whole product as AB plus AC plus AD. Isn't it easy? Just try the remaining parts. Match your answers if you have completed and leave a comment if anything is not clear. Now question 3 contains product of monomials which you have already practiced in previous exercise. So let's solve it quickly. We have to multiply first the numbers and then the similar variables. In question 4, we first have to simplify the expressions and then the value of the resulting answer obtained will be found for the given value of the variable. So in first part, let's first simplify this. As per BODMAS, we will first multiply. So we have 3x into 4x minus 3x into 5 plus 3, which is equal to 12x square minus 15x plus 3. As there are no like terms, this is the final answer. Now to find the value of this expression at x equal to 3, we have to replace x by 3 everywhere, and thus we get 12 into 3 square minus 15 into 3 plus 3. Wherever you see powers, first solve them. So we have 12 into 9 minus 45 plus 3, which is equal to 108 minus 45 plus 3. Now either add like terms or subtract unlike terms. I'm adding the like terms 108 and 3. So we have 111 minus 45, that is equal to 66. Similarly, for the second part, replace x by 1 upon 2 everywhere. So we get 12 into 1 upon 2 whole square minus 15 into 1 upon 2 plus 3. On simplifying this, we get 3 minus 15 upon 2 plus 3. As one of the terms is a fraction, we have to take LCM to solve further. And so we have 12 minus 15 upon 2 or minus 3 upon 2. Are all the steps clear? Don't hesitate to ask if you have any doubts. Let's try the next part now. First, we will simplify this expression as per BODMAS. So finally we get a cube plus a square plus a plus 5. Now for the first part, put a equal to 0 everywhere. And finally the answer is 5. In second part, we have to find the value for a equal to 1. So replace it by 1 everywhere. And we get 1 plus 1 plus 1 plus 5, which is equal to 8. In the third part, we have to replace a by minus 1 everywhere. We know that even power of a negative number is positive and odd power is negative. So we have minus 1 plus 1 minus 1 plus 5, which is equal to 4 on solving. Now comes question 5. Here you have to understand and follow the instructions given in each part. So can I write a part as this? If you are afraid of this long chain of expressions, you can also solve each part separately and then add 3 answers using column method. So solving the first expression, we get p into p minus p into q equal to p square minus pq. On solving the second one, we have q into q minus q into r equal to q square minus qr. And the third one becomes r square minus pr. Now we will write these 3 one below the other in such a way that like terms come below the like terms, and then we will add them. As there are no like terms, this is the answer. So this was how we can use the column method. Now let me discuss the horizontal method also. If you understand and practice it, you will find that this is much simpler than the upper method, and it is also faster. So try at least one question with this method. This expression has 3 parts, each containing a product of monomial and binomial. So we will be solving each part separately but side by side. From the first part, we get p into p minus p into q. Then from the second one, we get plus q into q minus q into r, and similarly plus r into r minus r into p, which becomes p square minus pq plus q square minus qr plus r square minus pr. Do you find any like terms? No. So this is the answer, and you can see it is same as the previous answer. So now try the next 2 parts yourself. I am here to help you if you find any problem. In the D part, we have to subtract this expression from this, and as this one is containing brackets, it is not a simple expression. So first we will simplify this. The monomials before the brackets will be multiplied with each term of the bracket. So we have 3a into a plus 3a into b plus 3a into c, and minus 2b into a plus 2b into b minus 2b into c, which simplifies to this. And this doesn't have any like term. Now we have to subtract this from the other expression. Mark this point that whenever we have to subtract a polynomial, we will have to put it in brackets. So 4c into minus a plus b plus c minus inside bracket this expression. As per BODMAS, we have to open the brackets, and while opening, wherever there is a monomial before it, we will multiply that monomial with each term. So we have minus 4c into a plus 4c into b plus 4c into c. As the second bracket has minus before it, all the signs will change. So minus 3a square minus 3ab minus 3ac plus 2ab minus 2b square plus 2bc. Now quickly find like terms and add them and write the next step. We have two terms of AC, so minus 4 minus 3 becomes minus 7 AC. Similarly, two terms of BC, so we get 4 plus 2, 6 BC. Minus 3AB plus 2AB gives us minus AB. The remaining terms are not like terms, so we write them directly. Remember that in algebra, order of the terms does not matter, so you may have got different order, but the specific terms should be same as mine. Children, if you have any doubts, any question, do ask me, and practice this method again and again, and then you will find this topic very easy and interesting. So this is all for today. Stay safe and don't forget to like, share and subscribe. Goodbye till we meet again.